Assalamualaikum and a very good evening to Dr. Hamdan. Today we're going to be recording the heat and mass transfer assignment video. I will first introduce myself. My name is Farah Aina binti Azhar. My metric number is 190632. Sorry.
My name is Nora Misamsua Biadenan. My metric number is 188334.
My name is Ali Faris and my metric number is 190684. So now we will introduce our question. A heat exchanger is a device used to transfer heat between a solid object and a fluid, or between two or more fluids. The fluids may be separated by a solid wall to prevent mixing, or they may be in direct contact. They are widely used in space heating, refrigeration, air conditioning, power stations, chemical plants, petrochemical plants, petroleum refiners, natural gas processing, and sewage treatment. So the classic example of a heat exchanger is found in an internal combustion engine, in which a circulating fluid known as engine coolant flows through radiator coils and air flows past the coils, which cools the coolant and heat the incoming air. Another example is the heat sink, which is a passive heat exchanger that transfers the heat generated by an electronic or a mechanical device to a fluid medium, often air or a liquid coolant. So example of heat exchanger in daily life are shell and tube heat exchanger, compact heat exchangers, plate and frame, and printed circuit heat exchanger. So the question given to us is that Corinza Partners designed a shell and tube heat exchanger to operate with a maximum discharge temperature of a hot stream to be cooled to 40 degrees Celsius. So once the unit was installed and running, the exchanger operated with a discharge temperature of 75 degrees Celsius. Rather than purchase a new exchanger, what options are available to bring the unit into compliance with the specified design temperature? We should also include will be affected if the unit is a shell and tube exchanger. That's it for the question. Now Farah will answer the question.
So now I will answer the question that was given before. So for the solution, firstly we ask the question how to bring the unit into compliance with the specified design temperature. So there are multiple ways to bring it into compliance, such as we can clean the heat exchanger and make sure that there are no dust on it. Also, we can install or remove insulator in case we want to change the temperature. Moreover, we can also correct the leakage if it happens, because if there is leakage, say there's water leakage, hot water leakage, that means the heat exchange cannot occur properly. Other than that, we can also upgrade or replace the gasket heat exchanger, and we can also increase the surface area of heat exchanger. By increasing the surface area of heat exchanger, we are able to make sure that the heat are able to be exchanged more efficiently. Lastly, we can also change the cooling medium of the heat exchanger to a more efficient cooling medium. So number 2, how your answers will be affected if the unit is a shell and tube exchanger. Actually, there's no difference. As long as it's a heat exchanger, then all the above mentioned points can be done to increase the efficiency. We can bring the unit into compliance by increasing the surface area of the heat exchanger. This can be done by mounting metal fins on the tube in such a way that there is good metallic contact between the base of the fin and the wall of the tube. With this contact, the temperature throughout the fins will approximate that of the temperature of the heating medium and the high thermal conductivity of most metal fins. So this can actually be proven with the fin equation. As you can see here, the heat transfer, the Q is directly proportional to H, which is the convection coefficient, and surface area. So by attaching metal fins, we are actually increasing the surface area, which will also increase the heat convection, which will also increase the heat transfer. Because in the question, you can tell that the temperature that is discharged is at 75 degrees Celsius, although well in actual they want for the water to discharge at 40 degrees Celsius. That means not the heat transfer is not enough. So now I will pass it to Amri to answer it further.
Okay, now I will continue with para part. Okay, from the question we know that there are a few ways to increase the ratio of heat exchanger. First, we can follow the installing guidelines. This means that increase the efficiency of the heat exchange begin with getting the installation of the device absolutely spot on. If you have bought the heat exchanger from the reputable manufacturer, you are sure to have received a set of installation guide from the maker of the device. So you must follow the installation guideline correctly. Okay, next is we can increase the efficiency of heat exchangers by changing the flow rate. Whenever technical come in for routine inspection and repair work, you can ask them to check if the flow of fluid in both primary and secondary side of heat exchange has the correct velocity. By this, you can increase the flow rate and change the capacity of the heat exchange to transfer heat. That means that you not advised to not necessarily increase the velocity, as it adds on the mass and make it more difficult for energy to be removed. The third way to increase the efficiency of heat exchange is by removing corrosion. If there is any corrosion, we must remove immediately if you don't want the device to become inefficient. Sometimes the corrosion will become so bad that you need to have the cube plate replaced. Make sure your technical carry out all necessary removal and replace for the operating heat exchange. So it will increase the efficiency of the heat exchange. Next is you can see the structure of shell and tube heat exchange. This is tube outlet and tube inlet. So this is shell inlet, shell outlet. The process we going this way and this we going this way. So this is the real picture of the shell and tube heat exchanger. Okay. After that, the conclusion and recommendation. Okay, as a conclusion, shell and tube heat exchangers has many advantages compared to another heat exchange. Shell and tube exchange can handle a heavy duty and high temperature and pressure. So this is one of the advantages that another heat exchanger cannot have. Okay, next advantage of the shell and tube heat exchanger is it is easy to control and operate well. It is not difficult to operate the item, so it easy. Any question? Okay, we know that there is a few ways to increase the efficiency of heat exchange. It is important to make sure that we use the item correctly to make no accident or unexpected thing happen during handling this item. Okay. Next is that's all. This reference